Today, we're taking another look at area and perimeter. This time, we're looking at what we call composite figures. These are figures that are different types that are put together. Think of your basketball court. You remember how you've got where you do the free throws? The free throw has a line and then it's got a semicircle. That is the idea behind a composite figure. That would be one type of a composite figure. So, how do I find perimeter and area of figures is the essential question. I'm learning to find the perimeter and area of composite figures is your learning intention. Pause the video now and see if you can do the missing length of these two similar figures. Do you remember how to set up those equivalent fractions? Pause the video and see if you do. Well, I hope you tried. So if we're looking, we notice that we've got 7 and we've got 91. We've got 7 and 7, 91 and 91. So 7 will match 91. Now we know that 11 has to also match x. You can either go from side to side on the figure, or you can go from figure to figure. If I go from side to side, I do 7 over 11 equals. 7 is smaller, 11 is bigger. It would be 91 over x. How do I know the 91 goes on top? Because 7 and 91 are in the corresponding position of the two similar figures. To solve, multiply at that diagonal and then divide going up. (91) times 7 divided by 11, and you end up with, oh, I put it in wrong, didn't I? 91 times 11 divided by 7, and it is 143. Okay, now 11 is greater than 7, 143 is greater than 91. So that is a quick check to make sure we're doing it right. Okay, for the next one, we've got to decide which sides match up. If I'm looking at these long pieces, does 12 match up with 81 or does 12 match up with 91? Does 12 match up with 84 or with 91? If I'm thinking about it, if I'm looking at it, this is my little piece that goes up to my bigger piece. This 84 would be in the same position as 12. So I know that those are in corresponding positions. They match up. That also means that the x and the 91 match up. So do you want to go 80? Let's see, we did it from side to side here. Let's go from figure to figure. 84 over 12 is equal to 91 over x. Remember, we multiply at the diagonal. So it'll take 91 times 12, then we'll divide by 84. We end up with 13. So if you're looking at this, we know that x has to be greater than 12 because 91 is greater than 84. So we are pretty sure we've done it correctly. So finding the area of composite figures, you need to remember 4 different things. Number 1, identify the correct formula to use. Number 2, identify the correct numeric value for the variables in that formula. 3, substitute the numeric values into the formula, and 4 means to solve. So find the perimeter and area of this figure, round up to the nearest tenth. For the perimeter, do we have all the edges we need? No. But we do know that if this is 12 yards, this too is 12 yards. We have a triangle, but we do not have the hypotenuse. This would actually be a right triangle. Whose formula do we use to find the length of a part of a right triangle? The Pythagorean. We know that this whole thing is 18. If the whole thing is 18, this piece here must be 9. And this is also 9. We won't be using them, but we need to find that missing piece, that missing hypotenuse. So, a squared plus b squared equals c squared. Does it matter which is a and b? No. 9 squared plus 7 squared equals c squared. What is the opposite of squaring? Square rooting. So, the square root of 9 squared plus 7 squared is equal to c. We're going to do it all at once so we don't make an error when we're trying to get things inputted. Second, x squared. 9 squared plus 7 squared. That gives me 11.4. We'll round to the nearest tenth. Now, 11.4 goes here and 11.4 goes here. As we're finding that perimeter, $11.4 times 2 plus, we've got 12 times 2 plus 18 is the base. So plug and chug. Two times 11.4 plus 2 times 12 plus 18, putting it all together, 64.8. So 64.8 is the perimeter. Are we done yet? No. You have to list the units you're in. So I'm looking back at my figure. This is in yards. Okay, what about the area? What 2 figures do you see there, and how will we use that? We see a rectangle and we see a triangle. The area of the rectangle is definitely the easier one to find. Just simply the base times the height. So this would be 12 times 18. $216. Yards squared. But What about the triangle? How do you find the area of a triangle? Base times height divided by 2. Now, if the triangle would have been 7 yards instead of, or 12 yards instead of 7, we could have simply cut that in half, divide it in half. But it's not. So we've got to go through the whole 9 yards. So the whole base is 18 times the height, which is 7. Then you divide by 2. You get 63. My brain immediately goes to half of 18 is 9. 9 times 7 is 63. This will be 63 yards squared. That's a terrible 3. Am I done yet? No. I've still got to find the total volume, or the total area. So your area will be equal to 216 plus 63. Your area is equal to 279 yards squared. So, hopefully that one wasn't very difficult for you. You're finding the area of a rectangle and a triangle. You've been shown that many times in the past, I'm sure. So, any questions? Back the video up and look at it again. Now this one's interesting. We've got a rectangle, and part of a circle. How do we find that? What are the pieces we can put in because we know that they're going to be equivalent? We're going to have 3 centimeters here. We'll have 5 centimeters here. This will be 5 centimeters, and this will be 3 centimeters. We've got a missing piece. What does that missing piece look like? Well, it looks like part of a circle. How much of a circle? Well, you're taking 90 degrees out of a circle. 90 degrees divided by 360 degrees is 1/4. So you're looking at 1/4 of a perimeter. Now, this one we will have to estimate because we're going to have to leave a pi in it or use pi, and then you'll only get the approximation. We prefer to get the approximation. So, what is my circumference of that circle? So we need the circumference is equal to 2 pi r. Okay, we know the r is 3. But we still have to divide it by 4 to get 1/4 of the circle. 2 pi times 3. I get 16.8449. I'm going to round it to 18.8. Let's go ahead and go to 8.5. you get 4.71. So it will round to about 7.1. 4.7. Got my numbers inverted there. Okay, now we're going all, the perimeter is all the way around. Three plus 5 plus 4.7 plus 5 plus 3 plus 5 plus 5, 3, 5, circumference, 5, 3, 5, 5. Three plus 5 plus 4.7 plus 5 plus 3 plus 5, 75.7. And that would be centimeters. What about the area? Well, you have two rectangles, which the area of a rectangle is base times height. And the area of a circle is equal to pi r squared. But is it a whole circle? No, we'll have to divide it by 4. Okay, your base and height here are 3 and 5. And those are identical. So the area of each of those is 15. Okay, so we're going to get pi times, what's our radius? 3 squared divided by 4. .06, that would round up to about 7.1. Now to find the whole area, we've got 2 that are 15 plus 1 that is 7.1. So our area is about 2 times 15 plus 7.1. 37.1. What are we in? What units are we in? Centimeters, and it will be centimeters squared. Area is always to the second power. You're dealing with 2 dimensions, length and width. So it will be units squared. Okay, now, if all we're doing is looking at 2 circles, and we're going to leave it in terms of pi. If this is 36 to here, then the other goes, you can't see it very well, but it would go all the way to the outside. Let's see if I can put a color that you would be able to see there. So that just includes that little piece there. Still can't see it good, but you know what I'm talking about. So circumference is equal to pi 2 pi r, or pi d. In this case, we know the radius. So for the first one, it will be 2 times pi times 36. But we're leaving it in terms of pi. So in our calculator, we're just simply going to take 2 times 36, and we get 72. Okay, the other one has a radius of 50. So for our circle 2, 2 times pi times 50. Well, 2 times 50 is 100, so this one is 100 pi. What is your total? Okay, so we did the perimeter, but we didn't ask to, we were not asked to add them together. If it would have said the perimeter of the shaded area, we would add them together. But we want to have the area of the shaded region. How do we find area of circles? In one case, r is equal to 36. In the other case, r is equal to 50. So, how do we find just the shaded region? What do you know? Well, the middle is not shaded, so we need to remove it. Remove means we do what? Divide is the correct, or subtract is the correct answer. So to remove it, we pick it up and get rid of it. So for the larger circle, pi times 50 squared minus pi times 36 squared. What we need to look at is 50 squared minus 36 squared. And that is followed by pi. The numbers are what you're going to put in the calculator and leave it in terms of pi. $50 squared minus 36 squared. $979. And followed by pi, and that would be feet squared. Okay, do you want the approximation? A lot of times you might. So in the calculator, 979 pi is about. Okay, I've got the 979 in there. Hit multiplied by, and then get your pi symbol. 3075.6. And that would be feet squared. So how do you know you're successful? You know you're successful when you can find the perimeter and area of composite figures. So, use the formulas. And then you'll have to identify the missing pieces. Identify the variables. Then solve.